Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. Welcome to Thermodynamic lecture series. Today we will talk about the steam tables. Steam tables are used in thermodynamics related problems. As we know that thermodynamics has got various applications in many fields like power plants, refrigeration, air conditioning, IC engines, heat and mass transfer. So also to solve problems related to power plants, we need the use of steam tables. So in today's lecture we are going to discuss the property tables, steam tables, types of steam tables, temperature and pressure tables. There are various types of steam tables used, and saturated, superheated and compressed liquid tables based on the state of the water or liquid. Liquid is a general word and water is a very specific word. We will specifically talk about the steam or water tables because it has got many applications in thermodynamic field. And finally we will discuss about the types of property tables based on units. Not finally, but we will talk in parallel because various steam tables has different units. So why we need property tables? For most substances, the relationships among thermodynamic properties are too complex to be expressed by simple equations. So therefore, properties are frequently presented in the form of tables. Some thermodynamic properties can be measured easily, but others can't and are calculated by using the relations between them and measurable properties. So the results of these measurements and calculations are presented in tables in a very convenient format. This is the TV diagram. We have discussed this diagram in the properties of substance lecture as well. But the purpose of this diagram again to discuss is to know about various properties which are labeled and are present in the steam tables. For example, we have saturated liquid line and saturated vapor line, and these are the different values of pressures. For example, pressure P1 and pressure P2. So the properties of steam or water, in this case, specific case, liquid is suppose water. So for this side, saturated liquid line, we label the properties with subscript F. For example, we have specific volume, so we will represent specific volume with small v having subscript of small f. Similarly, if I denote the specific internal energy on this line, so it will be small uf. Also to denote the specific enthalpy on this line, this will be hf, and the entropy on this line, specific entropy on this line will be sf. Also to denote various properties on saturated vapor line, which is this line, So at this line we have the properties, which is specific volume of saturated vapor, specific internal energy of saturated vapor, specific entropy of the saturated vapor, and specific enthalpy of the saturated vapor. So we have temperature, pressure, and these properties in the tables. Also, coming to the tables, let's discuss them one by one. Suppose this is table A4, saturated water table, and this is saturated water table, temperature table. Table A5 is saturated water pressure table. Table A6, superheated water table. Table A7, compressed liquid water table. So these four tables are important to study. There are various tables, but our focus is on water tables or steam tables, so we pick them. So going to table A4, suppose this is table A4, which is saturated water temperature table. Why it is called temperature table? Because in these type of tables we have temperature in this column. The values of temperatures are mentioned in the left column. So due to this, it is called temperature table. The value of temperature are in degree centigrade. Pressure value is in kilopascal. Let me zoom it to see it clearly. Now this is the specific volume values which we talked about. This is VF, saturated liquid specific volume, saturated vapor specific volume VG, and the units of these volumes is measured in cubic meter per kilogram. Similarly, internal energy is measured in kilojoule per kilogram. UF, small uf, is the saturated liquid specific enthalpy, specific internal energy. UG is the saturated vapor internal energy, and UFG is basically the difference of UG and UF. Sometimes in some tables this value is mentioned, but in some tables it's not. If we take the difference of UG and UF, we will get this value. Similarly, if we look here into the specific volume, we have no values of VFG. We can also write VFG equal to VG minus VF. So we can also calculate the value of VFG from this table, where VFG is the specific volume of the saturated mixture, which is inside the loop of the steam. Similarly, if we look to this value, which is enthalpy measured in kilojoule per kilogram, again we have specific enthalpy of saturated liquid, specific enthalpy of saturated vapor, and the difference of these two, which is the enthalpy of the mixture of the saturated liquid and saturated vapor, which is represented by HFG. And this is the value of entropy measured in kilojoule per kilogram per Kelvin, represented by saturated liquid specific entropy SF, saturated vapor specific enthalpy SG, and this is the mixture specific entropy SFG. So these values are mentioned and picked according to the requirement of the problem. So going down, these values are mentioned up to 373.95 degrees centigrade. These values are mentioned. Similarly, this table FIO is about saturated water pressure table. Why it is called pressure table? Because we have the values of pressure in this column, which is on the very left side, measured in kilopascal. Temperature is measured in degrees centigrade. This is the saturation temperature. We have talked about the saturation temperature and saturation pressure. Again, we have values of VF, VG, UF, UFG, UG, HF, HFG, HG, SF, SFG, and SG as in temperature table. The difference is only here that we have pressure in the left column, and then we have saturation temperature values. So going down to the bottom of this table, we have this much pressure, which is in kilopascal, and 373.95 degree centigrade temperature, and other values are mentioned respectively. Similarly, going to superheated water table, table S6. In this table, if you observe, there is no VF, VG, HF, HG, because we denote those values for saturated liquid, saturated vapor, and mixture of the saturated liquid and saturated vapor. For pure superheated water or superheated steam, we use the notation V, U, H, and S. Respectively, we have pressures values. Here we have pressure 0.01 megapascal. Here we have pressure 0.05 megapascal, and the value of pressure is 0.1 megapascal. So at these different pressures, these values, properties are having some values, and values are picked looking to the pressure and the temperature according to the need of the problem. Again, if we look to the units, they are having same units: cubic meter per kilogram, for example, for specific volume; kilojoule per kilogram for specific internal energy; for specific enthalpy it is kilojoule per kilogram, and for specific entropy it is kilojoule per kilogram per Kelvin. So table S6 is, these are the values of table S6. The maximum limit of this table is pressure is 60 megapascal, and the temperature is 1300 degrees centigrade. Similarly, table A7 is about compressed liquid water. Again, we have simple values of simple V, U, H and S. There is no VF, VG, there is no UF, UG, because I talked earlier that those notation are used only in the study of saturated liquid, saturated vapor and its mixture. So again we have temperature in degree centigrade and pressure in megapascal. So for this, in this table only pressure 50 megapascal, the respective values are mentioned for each property, and temperature up to 380 degrees centigrade it has been mentioned, and pressure 50 megapascal, various values are presented. Similarly, going to another tables which are important to discuss, steam tables. These are also steam tables, saturated steam temperature table. Again we have temperature column on the very left side, that's why it is called temperature table. The pressure here is measured in bar. Sometimes according to the problem we have to use different types of tables. If we have given value in the problem in bar, so we will use this table. And the units of specific volume is cubic meter per kilogram. The unit of specific internal energy is kilojoule per kilogram. The unit of enthalpy is kilojoule per kilogram, and the unit of entropy is kilojoule per kilogram per Kelvin. So again we have the value of VF, VG, UF, UG, HF, HG, SF, SG. If you look to these values, we have some missed information over here. We can also calculate it from this. For example, VFG is missing, so we can find it from the difference of specific volume. Similarly, UFG is missing, so we can take the difference of UG minus UF. Similarly, HFG is equal to the difference of HG and HF. HG and HF are given over here. Similarly, SFG is missing, so taking the difference of SG and SF, we can find the value of SFG. So again, this is saturated steam, or sometimes it is called wet steam, or sometimes it is called dry saturated steam. So we have these notations. For compressed liquid and for superheated steam, we don't use these notation. We only use simple notations, small v, u, f, g. So going down and noting the values in the temperature table, temperature in degree centigrade, finally 374.14 degrees centigrade, pressure is 220.9 bar. All values are mentioned and their respective units are given over here. Similarly, coming to this table, which is saturated steam pressure table, we have pressure values in the very left side column, 0.04 bar, then temperature in degree centigrade, specific volume in cubic meter per kilogram, specific internal energy in kilojoule per kilogram, and specific enthalpy in kilojoule per kilogram, specific entropy in kilojoule per kilogram per Kelvin. So sometimes if we have given in thermodynamics problems or power plants problems pressure in bar, so accordingly we will use this table to explore other properties of the steam. This is superheated steam table. Superheated steam table, temperature T is here, pressure is in bar 0.06 bar, similarly pressure is 0.35 bar. So respectively the units of specific volume is cubic meter per kilogram, unit of specific internal energy is kilojoule per kilogram, and specific enthalpy has unit of kilojoule per kilogram, and specific entropy has a unit of kilojoule per kilogram per Kelvin. So at different pressures we have given the values of these properties with respect to temperatures. These are all about superheated steam tables. Also, coming to saturated steam temperature table, which has different units. Now here we have temperature in degree Fahrenheit and pressure in pound per square inch. Specific volume is in cubic feet per pound mass. Specific internal energy is measured in BTU per pound mass. Specific enthalpy is measured in BTU per pound mass, while specific entropy is measured in BTU per pound mass per degree Rankine, where BTU is the unit of energy, British thermal unit, pound mass is the unit of mass, and degree Rankine is also unit of temperature. Here are 4 scales of temperatures: degree Fahrenheit, Kelvin, degree centigrade, degree Rankine. So as we discussed that in some tables different units are used, so we have degree Fahrenheit values in this column. Respectively, the pressure in PSI is given in this column, and these values are measured in the specific volume is measured in cubic feet per pound mass. Specific internal energy UF, UG are measured in BTU per pound, HF, HG, BTU per pound mass, SF, SG, BTU per pound mass per degree Rankine. We can also calculate the values of SFG, HFG, UFG and VFG, just like the previous case from this table. So these are saturated steam tables, temperature tables, and temperatures in degree Fahrenheit. This is saturated steam pressure table. Here we have pressure in pound per square inch, temperature in degree Fahrenheit, and other units are, for example, specific volume cubic feet per pound mass, internal energy BTU per pound mass, enthalpy is BTU per pound mass, entropy is BTU per pound mass and per degree Rankine. So these values are again mentioned for the saturated steam, and the values of these properties are mentioned while varying the pressure. That's why this is called pressure table. These are the various values. Maximum value is 3203.6 psi, and the degree Fahrenheit value temperature is 705.4. All properties are mentioned in this table. Similarly, coming to superheated steam tables, again we have pressure in psi, temperature in degree Fahrenheit, specific volume cubic feet per pound, U BTU per pound mass, H BTU per pound mass, S BTU per pound mass per degree Rankine. So the temperature is in degree Fahrenheit while the pressure is in psi. So changing the pressure values accordingly by varying the temperature values, we have specific volume, specific internal energy, specific enthalpy, specific entropy, all values presented in these tables, superheated steam tables. So these various types of steam tables which we studied can be used in thermodynamics related problems. Depending upon the given data and given units, we will use these tables accordingly. So this is all about the property tables and steam tables, that how can we use steam tables for problem solution. Next lecture will be on properties of saturated steam. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.